We are going to apply these to real world situations. A ball is launched in the air with initial velocity of 40 feet per second. And the equation that models the height of the ball in terms of time is h of t is 40t minus 16t squared. What's the maximum height of the ball attained, and at what time does the ball attain that height? So what kind of shape does that graph make? Parabola that is right side up or upside down? Upside down, okay? So what point on the graph will tell us the maximum height? Starts with a V. Vertex. The vertex is the point where it reaches its maximum height. So in order to answer this question, all we have to do is find the maximum, or the vertex. You got two options. You can either put it into vertex form, or you can do negative b divided by 2a. I think most of you would choose. Oh. I think most of you would do negative b divided by 2a. So negative b would be negative 40 or positive 16. Which is it? Negative 40 divided by 2 times negative 16, or negative 32, which is 1.25. We're going to take that 1.25, we're going to plug it back into our calculator. And there's a few ways to do that. If you're like me, you plug it in here, 40x minus 16x squared. I usually type mine in there, and I go to my table, and I type in 1.25. I get 25. That's how I do it. That way, if I want to graph it or anything else, I can. But then I can find the multiple values if I need to. Okay? So let's make sense of it. What's my answer? If this is h of t, the y value is the height, and the x value is the time. So what is the maximum height? 25 feet. At what time does the ball attain that height? 1.25 seconds. So that coordinate right there was 1.25, 25. Make sense? Okay, we'll look at a different example, then we're done. I'll give you your worksheet and your assignment. A model for the food price index. There's something in economics we call CPI. That means Consumer Price Index. And what that means is it's a way for us to try to calculate how much goods have risen in cost over the course of a few years. So for example, do you think that when my mom was growing up, she paid more for a loaf of bread or less for a loaf of bread than what I did? Well, she probably paid, say, 10 cents, 25 cents, something like that for a loaf of bread. And when I get mine, I'd say I generally pay 89 cents at Fairway. That's what I pay. Okay. So you would say that if the CPI when my mom was buying bread was say 1, then the CPI when I was buying bread might be say 3 or 4 times that. Okay. So it might be 3.0 or 3.5 or something like that. Kind of measures inflation, right? And that would make sense. For example, let's say right now that I earn a wage of $50,000 a year, okay? And let's say that in 1900 somebody earned $25,000 a year. Who's actually earning more money? They are. $25,000 back in 1900s would be more like, I don't know, a few $100,000 right now. So it's a way to kind of measure what the price of goods are over a course of a certain amount of time. So what they do is they say that there's a model right here, and this fluctuates, okay? Because when I was your age, you know I was paying for a gallon of gas about $1.29, and then just 3 years ago I was paying $3.89, $3.95, and now when I drove down the freeway this morning, I saw Casey's had it for $2.06. So we've gotten a lot of uncertainty in the market right now, and oil prices are changing due to all sorts of things. So anyway, it's not real predictable, but there's a general relationship here. So it says that this is the model for the price index. So this is I of t is equal to that thing. Between 1990 and 2000, is given by that function, where t is measured in years since the mid-year of 1900, so 0 is less than t, which is less than 10. Anybody know what that means, this part right here? What is 0? 1990. And what is 10? Yeah, it's, they're not going to write an equation that places the years at 1990 and 2000. So the beginning year was 1990, the end year was 2000. So we go from 0 to 10. That's what that's saying. It says, when was the food most expensive over that time interval? So am I looking for a maximum or a minimum? I'm looking for a maximum. Is this a quadratic equation? No, it's the third power. You don't have a negative b divided by 2a for a cubic. If you want to find where this maximum is by hand, you have to know calculus. And we don't know that yet, okay? In fact, in calculus class, we're not getting into that for another week and a half or so. So we want to be able to figure this out. The only way we can do it is by using graphing technology, okay? We take out our calculator, and we plug this in, negative 0.0133 x to the third. What? All right, yeah. And plus, didn't I type that? Plus 0.0618 81 x squared. Yes, some days. Just with numbers. Plus 0.198 x plus 99.1. Now, here's the tricky part. If you graph this, a lot of people say there's something wrong with my calculator because I can't see it. Well, chances are there's not something wrong with your calculator, there's something wrong with you. Yeah. So we need to be able to figure out how to change that. So let's think, okay? Let's put on our thinking caps here. If this is my domain, what should I put my x values between? 0 and 10. Or if you're like me, I'm going to make it a little bit bigger. I'm going from -5 to +15. That way I will for sure see the window of 0 to 10. Second of all, can you tell me what is a reasonable y value that I would get for an output here? 99.1 is what on the graph? The y-intercept. So you can tell right now if this crosses the y-axis and then 99.1. So if you leave it at 0 to 10 or -10 to 10 for your y-axis, you're not going to see it. So I'm going to change my y minimum to, say, -10. I'm going to go all the way up to 300. And maybe I'll see a decent portion of the graph that way. Okay? So I press graph. I can see the graph, can I? Can you see its maximum? I don't. So I'm going to have to squish this window a little bit. This is about 100 right there. So I'm just going to go up to 120. So the Y max, I'm just going to bring to 120. And the Y minimum, I'm going to bring to 90. Now as I graph it, can you see the maximum there? That's a lot better, isn't it? If you don't like that, you could continue to, if you just scroll, you can see, well, say 102 and then 97. If you want to see a really good picture, change it again. Go 95 to 105. And we'll probably get a great picture now. So you got to be able to play with your technology to be able to figure out exactly where we're at. Now I can find the maximum. How do I find that? What do I do with my calculator? Maximum, yep. And I go to the left of that maximum. And then I go over to the right of that maximum. And I get a coordinate of 5.15 and 100.38. So what means what? What does 5.15 mean? What variable is it? Yep, time or year. And then 100.38 is actually the index price. So What year was food most expensive? 95. 1995. How's that? Okay, your assignment is just three problems from your book, and then I have a worksheet for you I'll hand out right now.